We're at a hinge point where those who internalize today's nuance will quietly build tomorrow's leverage. Welcome back to AI on AI, where we unpack the latest frontiers. Today, we're diving into agentic computer use models and the rise of on-device assistants that can actually click, type, and navigate for you.
Yeah, look, the shift from chat to action is here. Small, vision-centric agents now handle multi-step web tasks with pixel-in, action-out loops, and it's not just a novelty, it's changing productivity patterns.
From a business lens, on-device agents mean lower latency, better privacy, and fewer infrastructure surprises. It's like moving from a call center to a personal concierge, except the concierge is a self-driving cursor.
I'm excited and a little cautious. These agents must measure twice, click once, stop at critical points, and refuse risky tasks. Otherwise, they'll speedrun users straight into irreversible mistakes.
The big unlock is data. Synthetic pipelines now propose tasks across live websites, attempt multiple solutions, and verify outcomes with complementary judges. Alignment checks, rubrics, and multimodal evidence, not just wishful thinking.
And to track progress, a new long-tail benchmark landed, adding underrepresented segments, jobs, real estate, multi-item shopping, comparison tasks, so we're done browsing for browsing's sake.
Technically, the decisive move is ditching brittle scaffolding. Direct screenshots plus low-level actions. Click, scroll, type. Yield stronger cross-site generalization than parsing accessibility trees that lie like bad metadata.
Also noteworthy, small agents now complete tasks in fewer steps and with lean output tokens. It's like debugging spaghetti code in daylight instead of generating 5 pages of thoughts to find the submit button.
Let's unpack the synthetic pipeline. Task proposal, solving, verification. Sounds simple, but the devil's in the orchestration.
Task Proposal leverages seed URLs, random walks, and templated expansions. You get realistic goals like book tickets, compare prices, add 3 items, not vague browse this page.
In solving, a planner steers a browser actor, tracking a ledger, last action success, loops, satisfaction, critical points, so the system replans when stuck and pauses before anything irreversible.
Right, and those critical points matter. Before entering credentials or paying, the agent stops and hands control back. Think good input, good output meets fast is slow, slow is smooth.
Verification closes the loop. High-level intent alignment, rubric scoring for partial credit, and screenshot-based checks to squash hallucinations. No proof, no pass.
Recent event worth noting. An open-weight, efficient computer use model launched alongside that long-tail benchmark, signaling a push toward local, affordable agency rather than cloud-only behemoths.
The methodology scales. Millions of steps synthesized across diverse domains. Importantly, step length correlates with failure modes, so loop detection and last-action reasoning become first-class citizens.
I'll add a tool that helps memorization. The agent records key facts for later, reducing cross-page hallucinations like forgetting the price while comparing retailers.
Let's hit real-world cases. Where does this matter beyond DMOS?
Travel booking is classic. Select dates, filter by amenities, pause before payment. Also restaurant reservations with outdoor seating and allergy notes, ready to stop before confirmation.
Procurement flows, add multiple items to carts across vendors, compare totals including tax or shipping, then export a quote. No logins, no payments, just pre-checkout sanity.
Jobs portals find relevant roles, route to the proper form, summarize requirements. Critically, halt before any submission or personal data entry.
Healthcare scheduling. Navigate appointment systems, extract next available times, verify clinician details, and create a patient-friendly summary. Again, stop before consent screens.
Quick humor, my agent tried to optimize checkout once. We now teach it, if you don't know, don't go, which beats buying a pallet of avocados by accident.
For developers, think of it like robotics on the web. Perception, grounding, micro-actions, recovery. Plan, act, sense, repeat with a mouse instead of a gripper.
Strategy-wise, the winners will combine local inference for privacy with managed browser sessions for reliability. You want speed, but also reproducible state across flaky sites.
Any pushback on-device dominance? Are we missing something?
I'll be contrarian, screens are a workaround. The real leverage is structured APIs. Agents shouldn't click through CAPTCHAs forever. They should call resilient services where possible.
Fair, but users live on the web. Until APIs catch up, screen agents are the bridge. Assemble now, architect later.
I'll push back gently. Even with APIs, vision is necessary for layout changes, dark patterns, or missing endpoints. Pixels are the ground truth for the wild web.
Another tension: synthetic trajectories versus human logs. Synthetic is scalable, but does it mirror edge behaviors like misclicks under pressure?
We see gains with synthetic plus targeted hard tasks. Think curriculum learning for the browser, not random surfing. You teach compositional tasks and error recovery explicitly.
Safety-wise, refusals improved markedly. Agents decline harmful tasks and pause reliably on sensitive actions in controlled testbeds. Still not perfect, but trending right.
What about the economics? Are small agents actually practical?
Yes, they burn far fewer output tokens, thinking less, doing more, and still hit competitive accuracy. For many enterprise flows, elasticity and privacy beat maximal win rates.
Rule of thumb, shorten action chains, compress reasoning, verify outcomes. It's the fail fast, learn faster playbook adapted for web agency.
Governance update: regulators are sketching rules for autonomous agents. Audit logs, human handoffs, and safe defaults will move from nice to have to baseline.
Benchmarks keep evolving. The long-tail set will refresh periodically to stay live and objective, unlike static pages that silently drift and break old scripts.
Developers should sandbox agents, limit site access, and never share sensitive data. Trust but verify applies to models and websites alike.
Prediction: next year, small agents learn drag and drop, richer keyboard sequences, and video-aware workflows. Multimodal control expands beyond clicking boxes.
I expect hybrid systems: local agent for perception and actions, cloud planner for complex compositions, invisible orchestration, visible gains.
Last takeaways, one-liners, please.
Small can be mighty, pixels plus actions, not just tokens and talk.
Value lands where latency, privacy, and cost intersect. On-device wins plenty.
Safety is behavior, not a prompt. Stop at critical points. Log everything.
Synthetic data is a force multiplier. Verify like a skeptic.
Benchmarks should reflect goals, not tour. Measure outcomes, not clicks.
Think self-driving cursor with brakes. Plan, act, sense, repeat.
Human in the loop is a feature, not a crutch. Collaboration beats automation alone.
That's our show. Agentic AI is moving fast. Build responsibly, ship thoughtfully, and remember, sometimes the smartest click is the one you don't make. Don't miss the brief summary right after this.
Narrated by the AI voice of Shri. The main topic is how to build a small, efficient agent that can use a computer to complete real web tasks. Researchers present Fara-7B, a compact model that sees screenshots and takes actions like clicking, typing, scrolling, and visiting pages. Their central claim is that high-quality synthetic data enables strong abilities in small models. A synthetic data engine called Fara-7B generates realistic, multi-step web task demonstrations at about $1 each. Fara-7B proposes tasks from popular websites, attempts multiple solutions, and filters successful runs using several automated judges. Automated judges, cold verifiers, check alignment with the goal, score progress with a rubric, and confirm evidence from screenshots. A computer use agent is a system that perceives a screen and acts like a person to achieve a goal. A trajectory is the full sequence of observations, internal reasoning, and actions taken to complete a task. Fara-7B follows a pixel-in, action-out approach, predicting precise click coordinates directly from images. Pixel-in Action out means the model takes only screenshots and browser information as input and outputs low-level actions. This avoids dependence on accessibility trees, which are structured lists of screen elements used by assistive technologies. The training pipeline uses a planner called the orchestrator and a browser actor called the web surfer. The orchestrator plans steps, tracks progress, detects loops, and enforces stopping at risky moments called critical points. Critical points are moments before irreversible or sensitive actions, such as payments or sharing personal information. The web surfer interacts with live pages, reasons about state, and executes clicks, typing, and navigation. The system produced 145,000 verified trajectories across 70,000 unique domains. Fara-7B outperforms similarly sized agents on Web Voyager, Online Mind, 2Web, DeepShop, and a new benchmark. The new benchmark, called Webtail Bench, adds underrepresented tasks like real estate, job applications, multi-item shopping, and comparison shopping. Webtail Bench tasks are realistic, goal-directed, and judged with methods that align more closely with human reviewers. Notable examples include booking flights and hotels, reserving restaurants, buying tickets, planning activities, and correctly reporting when options are unavailable. The model is competitive with much larger frontier systems while using far fewer generated tokens per task. Tokens are the basic units of text that models read and write, which directly affect cost. Fara-7B averages only a few cents per task, lower than larger systems that consume many more tokens. The model completes tasks in fewer actions on average, reducing latency and cumulative token usage. A key insight is that relying on screenshots generalizes better than using imperfect accessibility trees across diverse websites. Another insight is that heavy internal reasoning increases output tokens, raising costs without guaranteed gains on dynamic pages. Verifier judgments agreed with human reviewers about 80% of the time, with some false positives and false negatives. Safety is a core focus, including refusing harmful requests and stopping at critical points for explicit user confirmation. Refusal means the agent declines tasks involving illegal acts, deception, or unsafe instructions encountered online. In controlled tests, Fara-7B refused harmful tasks more often than other computer-used models. In replication environments, it usually halted before critical points, limiting the chance of costly mistakes. Challenges include data scarcity, dynamic page content, looping behaviors, website defenses, and difficulty in multi-step, cross-site tasks. Limitations include no drag and drop, no audio or video understanding, and reduced accuracy on complex workflows. Open questions involve aligning automated judges with human judgment and handling adversarial or deceptive content more robustly. Scaling trends show steady gains from more training steps and allowing more actions during inference. Future work aims to strengthen grounding, scale data and model size, improve human collaboration, and standardize human evaluations. This matters because low-cost, private, on-device agents could make everyday web tasks faster, safer, and more accessible. If a specific insight resonated, send this podcast to a teammate and compare takeaways. Shared reflection compounds value.